Right now, you're not sitting still. You might feel like you're just watching a video, maybe lying on your bed or sitting at your desk, but in reality you're racing through the universe at mind-bending speeds. The ground beneath you is spinning at over 1,000 miles per hour as Earth turns on its axis, launching you eastward faster than the top speed of a fighter jet. That might already sound wild, but it's barely the beginning, because while Earth spins, our planet is also rocketing around the sun at 67,000 miles per hour. Imagine riding a roller coaster that never ends, where the track is so massive it takes a full year to complete just one loop. That's your orbit. But the story gets even stranger, because the sun, the very anchor of our solar system, isn't still either. It's dragging all of us along with it, like passengers clinging to a speedboat as it tears around the center of the Milky Way at over 500,000 miles per hour. Right now, as you hear these words, you're being hurled through space faster than any rocket humanity has ever built, faster than bullets leaving the barrel of a gun, faster than the blink of an eye could ever measure. And where exactly are we racing to? Toward a monster, toward something so immense and powerful that every star, every planet, every atom in our galaxy is trapped in its gravitational grip, a supermassive black hole. But before we reach that destination, our path takes us through one of the most astonishing journeys imaginable. Our galaxy isn't an empty void. It's alive, filled with neighborhoods of chaos and calm, with regions where stars are born in firestorms and others where ancient giants have already burned out, leaving behind corpses heavier than mountains crushed into the size of a city. You live inside this galactic machine without ever noticing its movement, without ever feeling the turbulence beneath your feet, and yet everything you are, from the iron in your blood to the calcium in your bones, was shaped by this journey. You are literally built from star ash, forged in furnaces that exploded billions of years ago, carried across space until it became part of you. And here's the paradox. For all the speed, for all the motion, you don't feel a thing. There's no wind in your face, no roaring engines, no rattling beneath your seat. The entire solar system is moving together in perfect sync, like a train gliding across invisible tracks through the darkness. But what surrounds this train is anything but quiet. On the outside of our bubble, stars are colliding, black holes are feeding, radiation storms are raging, and supernova shockwaves are carving scars across the galactic disk. Every moment, cosmic violence is unfolding all around us, and yet here you are, safe, calm, watching, unaware that the backdrop of your daily life is one of the most extreme environments in the universe. Tonight, we're not just going to tell you about it, we're going to take the ride from the quiet shelter of our local bubble to the stellar graveyards scattered across space, past the nurseries where new suns ignite, into the spiral arms that stretch like highways of stars, and finally into the blazing chaos at the heart of it all, where the Milky Way hides its greatest secret, the monster at the center, the supermassive black hole that binds our galaxy together while tearing apart anything that dares wander too close. So, buckle up, because once this journey begins, you'll never look at the night sky the same way again. The journey begins right where we are, in the solar system we call home, a neighborhood that seems familiar until you realize just how violently it's being carried through the galaxy. Most people picture the planets calmly circling the sun, like neat clockwork ticking away in silence, but the truth is far less peaceful. Our entire system is plowing through space at speeds that defy imagination, and every one of us is strapped in, whether we like it or not. Imagine the sun as a roaring speedboat tearing across a dark ocean, and all the planets trailing behind on invisible ropes, dragged along for the ride. That's you, Earth, Mercury, Jupiter, all of us, passengers being whipped across the galactic current at over 500,000 miles per hour. To put that in perspective, in the single second it takes you to blink, you've already moved more than 100 miles closer to the heart of the Milky Way. And yet we feel nothing. No pressure, no pull, no sense that we're cutting through the void at speeds faster than a rifle bullet. The silence of space is deceptive, hiding the fact that we are racing headlong into cosmic chaos. What's even stranger is that this path isn't a simple circle like Earth's orbit around the Sun. It's a vast elliptical track that takes about 230 million years to complete. One galactic year. Think about that. When Earth was last in this exact spot in its orbit around the center of the galaxy, dinosaurs hadn't even appeared yet. The continents looked nothing like the world map you know, and mammals weren't even a concept. Every trip around the Milky Way carries the story of life's rise and fall on our planet. With each revolution, new species emerge, civilizations rise, and entire ages pass. Yet the galaxy itself barely notices. We're like dust clinging to a wheel that spins endlessly on scales too vast for our minds to grasp. But this orbit isn't smooth. Just as a speedboat rises and falls with ocean swells, our solar system bobs up and down through the galactic disk, crossing its dense plane every 30 million years or so. These crossings are far from harmless. Some scientists believe that when we plunge through the crowded regions of the Milky Way, the increased radiation, the heightened asteroid activity, and the gravitational chaos could trigger mass extinctions back on Earth. It's like driving through a city. Sometimes you're in quiet suburbs with wide, empty streets, and other times you're pushed into the middle of downtown traffic, surrounded by flashing lights, collisions and noise. Right now, we're cruising through one of the quieter neighborhoods, a relatively empty patch of the galaxy, where life has been given the rare chance to thrive. But this calm is temporary. The galaxy is not a static place, and our solar system is constantly on the move toward regions where danger lurks. What protects us during this journey is something few people ever hear about: the local bubble. Picture a vast cavern carved into the galaxy, stretching for 1,000 light-years in every direction, and our solar system floating inside it like a speck of dust in a cathedral. The walls of this bubble aren't built from stone or glass, they're remnants of ancient explosions. The shockwaves of massive stars that ended their lives in spectacular supernovas millions of years ago. Those blasts pushed away gas and dust, clearing out a cosmic cavity that we now inhabit. It's ironic, really, the very violence that sterilized this region long ago may be the reason Earth had the peace and safety to evolve life. The bubble shields us from some of the harsher radiation of the galaxy, acting like a buffer zone, though its protection won't last forever. Eventually, in just a few million years, we'll drift to its edge and burst through into denser, more dangerous space. What waits for us there is uncertain, but it could change Earth's environment in ways we can't yet predict. For now, though, our solar system glides quietly within this hollowed-out scar of past destruction. The stars you see at night are often shining through the thin edges of this bubble, the glow of distant suns filtering past the faint shell of hot gas that surrounds us. We're passengers in a glass submarine, traveling through an ocean we can't touch, and as safe as this feels, the real adventure begins once we push beyond these boundaries. Because what lies outside the bubble isn't empty. It's teeming with creation and destruction. Regions where stars are born in firestorms and others where they collapse into the strangest objects in the universe. The calm of our local space is only a prelude to the chaos ahead, and every mile we travel brings us closer to the places where the rules of the universe are written in fire and gravity. As we drift beyond the protective calm of our local bubble, the scenery of the galaxy changes in dramatic fashion. Suddenly, the emptiness thickens. Vast clouds of gas and dust loom in the darkness, stretching across space for hundreds of light years, silent yet restless. At first glance, they seem lifeless, nothing more than giant cosmic fog banks drifting through the void. But inside these clouds, invisible to ordinary eyes, the raw materials of creation are gathering. Gravity pulls on every particle, slowly, relentlessly, until entire regions collapse in on themselves. And from that collapse, stars are born. It's here, in these stellar nurseries, that the galaxy reveals its most beautiful and violent side, a paradox of destruction and birth, playing out on a stage bigger than anything we can imagine. The closest example lies only a few hundred light-years away in the Orion Molecular Cloud Complex, a star factory hidden in plain sight behind the familiar pattern of Orion's belt. If our eyes could see infrared light, this region would blaze brighter than almost any other spot in the sky, glowing with the heat of thousands of newborn suns. Picture a cloud so immense that light itself takes years to cross it. A mist of hydrogen and dust, denser than the regions of space we're used to. As gravity squeezes pockets of this cloud, the material grows hotter and denser until nuclear fusion ignites at its core. In that instant, a star is born, and the darkness erupts with light that will shine for millions or even billions of years. But the process is far from gentle. When a new star ignites, it doesn't quietly take its place in the galaxy. It roars to life, blasting powerful winds of particles outward at hundreds of miles per second. These stellar winds carve tunnels and cavities through the surrounding cloud, sculpting shapes that twist like cosmic statues. Nearby regions collapse under the pressure, sparking new star births, while weaker fragments are ripped apart and scattered. It's a chaotic battlefield where only some clumps of gas survive to become stars, while others are destroyed before they ever fully form. From Earth, when astronomers aim their telescopes at these regions, the results are breathtaking. Glowing nebulae painted in reds, blues, and purples, vast wings of light shaped by radiation, the visual signatures of stars in their infancy. What makes these nurseries even more fascinating is that stars are rarely born alone. When a massive gas cloud collapses, it doesn't form just one star, but dozens or even hundreds. They begin life as siblings, packed tightly together in a small region of space. Our own sun was likely born this way, part of a crowded cluster with thousands of other stars about 4.5 billion years ago. Imagine the night sky back then. Hundreds of suns blazing nearby, some brighter than Venus ever appears to us today. Over time, gravity scattered those siblings across the Milky Way, and now they wander the galaxy anonymously, indistinguishable from the countless other stars shining above. Somewhere out there are the lost brothers and sisters of our sun, forever separated by the relentless churn of galactic motion. Not every collapsing cloud succeeds in producing a full-fledged star. Some fall short of the critical mass needed for nuclear fusion, becoming brown dwarfs, failed stars that glow dimly in infrared light. Others collapse into smaller fragments, torn apart by radiation before they can stabilize. But the ones that do survive are the engines of the cosmos. Every element heavier than hydrogen and helium inside your body, the oxygen in your lungs, the carbon in your cells, the iron in your blood, was forged inside stars that once burned in regions like these. And when those stars eventually died, they scattered their ashes back into the galaxy, seeding the next generation of star formation. In a very literal sense, we are children of these cosmic nurseries, built from the same materials that light up the Orion Nebula today. This cycle of birth and destruction has been repeating for billions of years, endlessly recycling the galaxy's gas and dust into new stars and planets. The regions we pass now are reminders that our solar system is not unique. Suns are being born all around us, some destined to shine quietly for billions of years, Others fated to live fast and die in explosions visible across the galaxy. As we leave the comfort of our bubble and venture deeper into these star factories, the peaceful illusion of the night sky begins to break, because behind every pinprick of light is a story of violence, gravity, and fire, and beyond the nurseries of creation lie the darker truths of what happens when stars die. For every dazzling birth of a star, there is an equally dramatic end, and it's in these deaths that the galaxy hides some of its strangest and most terrifying creations. Stars are not eternal, they burn through their fuel, and when that fuel runs out, their fates diverge depending on their size. Some fade quietly, others explode with the energy of billions of suns, and a few collapse into forms so bizarre they defy human imagination. As we venture further along our galactic path, we encounter these stellar graveyards, the remains of suns that once burned brightly, now transformed into cosmic relics of unimaginable density and power. The most common among them are white dwarfs, the fading cores of stars not unlike our own sun. When a star like this nears the end of its life, it swells into a red giant, shedding its outer layers until only its dense heart remains. That remnant, though no larger than Earth, contains more than half the mass of the original star. A teaspoon of white dwarf material would outweigh a car. These stellar embers start off hotter than 100,000 degrees, but without fresh fuel, they slowly cool over billions of years, fading into darkness. The oldest white dwarfs are so cold now that they glow only faintly, time capsules from an era when the galaxy itself was still young. They sit quietly in the night, remnants of what once was, reminders that even stars can grow old. But the graveyard doesn't end there. When a star far larger than our sun dies, the result is far stranger. After burning through their fuel, these giants collapse under their own immense gravity, squeezing atoms so tightly that protons and electrons fuse into neutrons. What's left is a neutron star, an object so dense that a sugar cube-sized piece would weigh more than Mount Everest. Entire suns are crushed into spheres barely 12 miles across, spinning at breakneck speeds. Some rotate hundreds of times every second, their magnetic fields trillions of times stronger than Earth's. These spinning corpses beam out radiation like cosmic lighthouses, their pulses so regular they rival the precision of atomic clocks. We call them pulsars, and when their beams sweep across Earth, we detect them as flashes of radio waves repeating with eerie consistency. Imagine a star that rotates faster than a blender blade while blasting energy across the galaxy. These are the ticking hearts of stellar death, and they remind us that the universe is both merciless and precise. Then there are the extremes, the remnants of the most massive stars of all, whose deaths tear the very fabric of space-time. When these titans collapse, nothing can stop gravity from pulling them inward. The result is a black hole, a region where matter is compressed into an infinitesimal point, and the pull of gravity is so strong that not even light can escape. These stellar mass black holes lurk invisibly throughout the galaxy, revealed only when they devour material from nearby stars, flaring with X-rays as the stolen gas spirals inward. They are silent predators, hidden until the moment they feed, each one a reminder that the life of a star can end in the most violent transformation imaginable. Traveling through the galaxy is like wandering through a cosmic cemetery. Everywhere around us are the remnants of suns that lived and died long before Earth ever formed. Some are still cooling, others still pulsing, and some waiting silently for their chance to consume. The strangest part is how close some of these objects really are. The nearest white dwarfs and neutron stars lie only a handful of light years away, making them among our closest neighbors invisible to the naked eye, yet powerful enough to warp our understanding of matter itself. They are not rare curiosities, but common features of the Milky Way, scattered in every direction, waiting in the shadows between the stars we can see. And yet, For all their danger and mystery, these stellar corpses also play a vital role in shaping the galaxy. Supernova explosions scatter heavy elements into space, seeding clouds that will become new stars and planets. White dwarfs, neutron stars, and black holes are not just cosmic leftovers, they are essential cogs in the great cycle of birth and death that keeps the Milky Way alive. Every atom in your body, heavier than hydrogen, was forged in a star that died long ago. The oxygen you breathe, the iron in your blood, the calcium in your bones, all of it passed through the fire of stars that ended their lives violently. In a very real sense, you are built from the ashes of stellar graveyards, a living monument to cosmic death. And as haunting as these remnants are, they are only part of the journey. Because if star birth and star death reveal the galaxy's power on a local scale, what lies ahead shows us the Milky Way's grand design. Beyond these graveyards stretch the great spiral arms, immense rivers of stars and gas that define the very structure of our galaxy, highways of light that carry us ever closer to the chaos at its core. Beyond the silent cemeteries of dead stars, the Milky Way begins to reveal its true shape. To the naked eye, the galaxy looks like a faint glowing band across the night sky, a dusty streak that ancient civilizations mistook for spilled milk or a river of light. But that hazy arc is just a tiny cross-section of something enormous. The spiral arms, vast currents of stars, gas and dust that wrap around the galaxy in sweeping arcs, tens of thousands of light years long. If the galaxy is a great cosmic hurricane, the spiral arms are its thunderous bands, glowing with energy, crowded with suns, and surging with the birth and death of stars. And our solar system, far from being a lonely wanderer, is woven into the fabric of one of these arms. We live inside the Orion Arm, sometimes called the Local Arm, a smaller branch that stretches for over 20,000 light-years. For decades, astronomers believed it was just a spur, a little offshoot between two major arms, but more recent discoveries have shown that it's much larger and more substantial than anyone realized. This is not a backwater. It's a major thoroughfare of the galaxy, a stellar highway where new suns are constantly being formed, and many of the constellations you recognize, the bright belt of Orion, the wings of Cygnus, the brilliance of Perseus, are all part of this very same galactic structure. Imagine the Milky Way as a glowing city seen from above. From Earth's perspective, we're not sitting on the outskirts, but right on one of the main streets, part of the living, breathing traffic of stars. But spiral arms aren't solid structures you could stand on. They're more like traffic jams on a grand scale. As stars and gas clouds orbit the center of the galaxy, they get bunched up in certain regions, slowed and compressed by density waves rippling through the disk. When massive clouds of gas enter an arm, the compression triggers collapses, sparking the birth of new stars. And once those stars ignite, they shine fiercely, marking the arms with brilliant light visible across thousands of light years. Some of these stars are titans, dozens or even hundreds of times more massive than the Sun, burning so hot they appear blue-white to telescopes, and living such short, violent lives that they explode in just a few million years. These giants are the signposts of the spiral arms, beacons announcing that here, in these crowded regions, the galaxy is alive with activity. Our solar system has likely drifted in and out of spiral arms many times during its 4.5 billion years of existence. Each passage reshapes the conditions around us. Inside the arms, radiation levels are higher, supernovae are more common, and the risks to life grow significantly. Outside the arms, in quieter inter-arm regions, the galaxy feels calmer, more like a cosmic countryside than a city. Right now, we're in one of these calmer spaces, but eventually we'll plunge into the traffic once more, carried along by the galactic orbit that never ends. Some scientists even speculate that mass extinctions on Earth may be tied to these passages, triggered when we cross into more dangerous neighborhoods filled with hazards invisible from our current safe zone. The Orion Arm is just one piece of this massive architecture. To our galactic east lies the Perseus Arm, one of the galaxy's grand highways, stretching like a glowing band across the sky. Here, some of the brightest and most energetic stars in the Milky Way roar with nuclear fire lighting up entire nebulae in their brilliance. To our galactic west sprawls the Scutum Centaurus Arm, even larger and longer, a chain of star factories wrapped around more than half the galaxy's core. These arms aren't just landmarks, they are the veins and arteries of the Milky Way, channeling matter, energy, and gravity in ways that define the entire structure of our home. From within them, it's nearly impossible to appreciate their true form. We are ants walking on the surface of a massive storm, unable to step back and see the pattern that surrounds us. But through generations of observation, mapping, and now infrared and radio telescopes that cut through the obscuring dust, we've slowly pieced together the picture. A barred spiral galaxy with great arms curling outward from its center, their bright knots of stars marking the beating heart of stellar creation. This is the architecture of our galaxy, and it is both elegant and violent, a balance of order and chaos that has shaped every star and planet, including our own. But as beautiful as these spirals are, they are not the destination. They are guides, streams that carry us inward, leading ever closer to the galactic center where the calm breaks apart and the true violence begins. Follow them long enough, and you arrive at the inner regions of the Milky Way, where the arms collapse into maelstroms of star clusters, giant molecular clouds, and gravitational forces so strong they can tear matter apart. The spiral arms are the path. The chaos at their end is the reality we're heading toward. As we follow the spiral arms inward, the galaxy around us grows denser, brighter, and more chaotic. The space between stars shrinks, and the quiet neighborhoods we once passed through are replaced by cosmic cities bursting with energy. Here, the Milky Way is no longer a calm expanse, with stars scattered politely apart. Instead, suns crowd together in vast clusters, so tightly packed that if Earth orbited one of them, our night sky would never be dark again. It would blaze with thousands of stars brighter than Venus, their combined light turning the heavens into a permanent twilight. This is the galactic core, the heartland of the Milky Way, where the balance between gravity and chaos teeters on a knife's edge. Among the most spectacular features we encounter are the globular clusters, ancient spheres of stars that have orbited the galaxy since its earliest days. Each one contains hundreds of thousands, sometimes even millions of stars compressed into regions only a few hundred light-years across. In our solar neighborhood, the nearest star lies 4 light-years away, but in the core of a globular cluster, stars can be separated by distances smaller than our solar system. Imagine standing on a world in such a place, where dozens of suns blaze in the sky, each one casting shadows in different directions. The beauty would be indescribable, but stability would be impossible. Planetary orbits would be shredded by the constant gravitational tug-of-war, and any hope for life as we know it would be extinguished in the chaos. These clusters are dazzling to behold, but they are also grave reminders of how hostile much of the galaxy truly is. Not all the star cities here are ancient. Scattered throughout the galactic disk are open clusters, groups of younger stars born from the collapse of enormous clouds of gas. Unlike their ancient cousins, open clusters are cosmic nurseries, still wrapped in wisps of dust and glowing nebulae. Some are small, with only a few dozen stars, while others contain thousands, still bound together by the gravity of their shared birthplace. Over time, these clusters unravel as their members drift apart, scattering across the galaxy until they are indistinguishable from the countless other stars in the night sky. Our Sun itself was once part of such a cluster, born alongside thousands of siblings roughly 4.5 billion years ago. Now those siblings are lost to us, scattered far and wide, invisible among the stellar sea. Between these crowded clusters lie vast molecular clouds, titans of gas and dust that dwarf entire solar systems. These are the raw materials of star formation, immense cosmic cauldrons where hydrogen atoms gather in the freezing dark until gravity forces them to ignite. The largest of these giants, like Sagittarius B2 near the galactic center, contain enough material to form millions of suns. They are not serene clouds, but turbulent, seething regions with their own internal storms. Radiation from nearby stars heats and stirs their surfaces, shockwaves from past supernovae ripple through their depths, and magnetic fields twist through them like invisible wires. Inside, temperatures plummet to just a few degrees above absolute zero, while molecules cling together in complex chains that may represent the first steps toward life itself. These clouds are both creators and destroyers, shaping the galaxy's future with every collapse and every explosion. The closer we move toward the core, the more extreme everything becomes. Stars burn hotter, live shorter lives, and die more violently. Radiation floods the environment, making it one of the most hostile regions in the Milky Way. Here, the calm balance that allowed Earth to nurture life is shattered. This is the industrial zone of the galaxy, where the machinery of creation and destruction runs at full tilt, generating brilliant suns, spectacular nebulae, and explosive deaths in a never-ending cycle. And yet, all of this is only a prelude to what lies ahead. Because deeper still, at the very center of it all, gravity itself begins to bend the rules, and the stars whirl around something so powerful that even light cannot escape its grasp. Ahead of us waits the greatest secret of the Milky Way, the monster that anchors the galaxy and devours everything that strays too close. At the very center of the Milky Way, hidden behind veils of dust and shrouded in mystery for most of human history, lies the monster that rules it all. Sagittarius A, the supermassive black hole, a gravitational anchor so powerful that every single one of the galaxy's hundreds of billions of stars is caught in its grip. For decades, astronomers suspected something immense was lurking there, but only in recent times have we been able to prove its existence by watching stars whip around it at breakneck speeds. Imagine suns, each one larger and brighter than our own, orbiting an invisible point so tightly that they complete their entire paths in just a matter of years. One star, known as S2, hurtles past the black hole at over 25 million miles per hour, so fast it could travel from Earth to the Moon in less than 30 minutes. The only thing capable of driving such impossible orbits is a mass 4 million times that of our Sun, crushed into a space smaller than Mercury's orbit. Yet, for all its violence, Sagittarius S appears deceptively calm most of the time. Unlike the raging quasars in distant galaxies that blast out jets visible across billions of light years, our black hole is currently in a quiet phase, feeding only occasionally on stray gas clouds and unlucky stars. But when it does feed, the spectacle is staggering. The event horizon itself, the boundary beyond which nothing can escape, is both simple and terrifying. It's not a surface you could touch, but an invisible sphere where space and time become so warped that every direction points inward. For us, watching from a safe distance, anything falling toward the black hole would appear to slow down as it approached the horizon, its light stretched into longer and longer wavelengths until it faded into invisibility, frozen on the edge forever. But for the doomed object itself, there would be no pause, no warning, just a smooth passage across the point of no return, followed by a one-way journey into a realm where the laws of physics, as we know them, cease to function. The forces near the event horizon are beyond comprehension. Tidal gravity grows so extreme that anything with size would be torn apart, atom by atom. A process grimly nicknamed spaghettification. Your feet, pulled harder than your head, would stretch you into a thin thread of matter long before you even realized what was happening. And time itself bends here. Clocks run slower near the horizon, so much so that from our perspective, anything approaching the black hole ages infinitely slowly. It is a region where the very concept of time becomes distorted, where seconds can stretch into eternity. In 2019, astronomers finally captured an image of this monster's shadow using a network of telescopes spread across Earth. The Event Horizon Telescope, what they saw matched decades of predictions. A glowing ring of fire surrounding a perfect circle of darkness, the silhouette of the event horizon itself. It was humanity's first direct glimpse of the abyss at the center of our galaxy, a cosmic reminder of how small we truly are compared to the forces shaping the universe. And yet, Sagittarius A is not only a destroyer. In its strange way, it is also a creator, the very reason the Milky Way exists as it does. Without its immense gravity, the spiral arms would unravel, the stars would drift away, and our galaxy would lose its structure. The monster at the center is both executioner and architect, tearing apart the unlucky while holding the rest together in its unseen embrace. Every orbit we make, every star we see, every planet that formed, owes its stability to this dark engine of gravity. We've reached the heart of the Milky Way, a place where space collapses, time distorts, and matter itself surrenders to something beyond comprehension. But the story doesn't end here, because even beyond this black hole's event horizon, the galaxy continues, connected to something even larger. Invisible forces of dark matter, sprawling superclusters, and the unimaginable scale of the cosmic web. And to understand where we truly live, we must zoom out once more, leaving the black hole's shadow behind to glimpse the skeleton of the universe itself. As overwhelming as Sagittarius A may be, it is not the whole story of our galaxy. In fact, most of what holds the Milky Way together is not even visible to us. Beyond the billions of stars, beyond the spiraling arms and glowing clouds of gas, lies a hidden framework. An invisible halo made of something we still don't fully understand, dark matter. It outweighs everything we can see by a factor of 10 to 1, and yet it emits no light, no heat, no signal that our instruments can detect directly. We know it's there only because of the way it tugs on the galaxy, the way it bends the path of stars and warps the very structure of space around it. Without this mysterious substance, the Milky Way could not exist as we know it. Its spiral arms would spin apart, its stars would scatter, and gravity alone from visible matter would never be enough to hold everything in place. Astronomers first suspected dark matter when they measured how fast stars orbit the galactic center. Far out on the galaxy's edges, stars were whipping around far too quickly, as if being pulled by an unseen hand. Based on the visible mass alone, these stars should have flown off into intergalactic space long ago. Something immense and invisible had to be anchoring them, and that something is what we now call dark matter. It forms a halo that extends far beyond the galaxy's visible edge, a diffuse sphere that stretches at least 600,000 light-years across, enveloping the Milky Way like a ghostly cocoon. If you could somehow see it, our galaxy would appear as a bright spinning disk suspended inside a vast faint globe of shadow, a jewel held in an invisible hand. But the dark halo is not uniform. Simulations suggest it is laced with substructure, clumps, filaments, and streams that weave through it like cosmic currents. Some of these clumps may be remnants of smaller galaxies torn apart by the Milky Way's gravity, their stars scattered while their invisible scaffolding remains. Others may be primordial knots of dark matter, structures that formed in the earliest moments after the Big Bang and have survived unchanged for billions of years. Whatever their origins, they add complexity to a halo that is already beyond comprehension. We live within this unseen sea, bathed constantly in a dark matter wind as our solar system speeds around the galaxy. Every second, countless dark matter particles may be streaming through your body, indifferent to your presence, ghosting through Earth as if it isn't even there. And yet, despite its abundance, no one has ever caught a dark matter particle in the act. The best laboratories on Earth are buried deep underground, waiting for the faintest signal of interaction. So far, nothing. The mystery remains intact. The role of dark matter in shaping the Milky Way cannot be overstated. In the early universe, before galaxies even existed, dark matter gathered first, clumping under its own gravity to form the skeletons of cosmic structure. Normal matter, hydrogen, helium, and later heavier elements forged in stars fell into these wells, lighting them up with stars and galaxies. Without dark matter's scaffolding, the Milky Way would never have formed, and neither would the stars or planets that now make up our home. Even now, the halo continues to dictate the galaxy's fate. It governs how the spiral arms rotate, how satellite galaxies orbit, and even how our galaxy interacts with its neighbors. Every motion we make, every orbit we trace, is happening inside this invisible cage. For all its importance, dark matter is still one of science's greatest enigmas. Is it made of exotic particles beyond the reach of current physics? Is it tied to hidden dimensions, or something even stranger, like a flaw in our understanding of gravity itself? We don't know. What we do know is that this invisible substance defines the shape of the Milky Way, binding together stars, gas, dust, and us in a gravitational embrace that stretches beyond anything we can see. We are inhabitants of a galaxy we only partially understand, living on the thin, glowing skin of an object that is mostly dark. And yet, even this massive structure, the stars, the black hole, the spiral arms, the dark matter halo, does not stand alone. Surrounding the Milky Way are dozens of smaller galaxies, caught in our gravitational pull, circling us like moons around a planet. Some are already being devoured, their stars stretched into streams across the night sky. Others remain intact, faint companions waiting their turn to be swallowed. Together, they form a family, a galactic ecosystem constantly in motion. And beyond them, even greater structures wait, because the Milky Way is only one member of a vast community of galaxies, a local group drifting together through the void. Our cosmic address is about to expand again, from a single galaxy wrapped in darkness to a cluster of galaxies bound by gravity on an even grander scale. The Milky Way may feel enormous, with its hundreds of billions of stars and its vast spiral arms stretching for 100,000 light-years. But it does not exist in isolation. Like a giant surrounded by a swarm of smaller companions, our galaxy is orbited by dozens of satellite galaxies, each one bound to us by the invisible pull of gravity. Some of these companions are bright enough to see with the naked eye, from the southern hemisphere glowing as faint clouds against the night. Others are so dim that they remained hidden until recently, detected only by careful surveys of the sky. Together they paint a picture of a galactic family, a system of giants and dwarfs constantly tugging on each other, reshaping themselves through endless gravitational encounters. The most famous companions are the Large and Small Magellanic Clouds, irregular dwarf galaxies that appear as misty patches in the southern sky. The Large Magellanic Cloud alone contains around 30 billion stars, making it the fourth largest member of our galactic neighborhood. It harbors active star-forming regions like the Tarantula Nebula, a colossal stellar nursery glowing with the light of hot young suns. Its smaller sibling, the Small Magellanic Cloud, though only a tenth as massive, still contains billions of stars and supports its own complex structure. These two galaxies are not passive satellites drifting peacefully around the Milky Way. They are in the process of being torn apart, their gas and stars stretched into streams by our galaxy's superior gravity. Trailing behind them like a galactic contrail is the Magellanic Stream, an immense river of hydrogen gas more than 600,000 light-years long, longer than the entire Milky Way itself. Over billions of years, this stream will funnel material into our galaxy, fueling new waves of star formation. Beyond these prominent clouds, the Milky Way is orbited by more than 50 smaller dwarf galaxies, with names like Draco, Ursa Minor, and Sagittarius. Many of them are so faint, they barely qualify as galaxies at all, containing only a few thousand stars scattered across their dark matter halos. Some, like the Sagittarius dwarf galaxy, are already in the process of being devoured, leaving behind long tidal streams of stars that wrap around the Milky Way like cosmic ribbons. In the far future, these faint companions will vanish completely, their stars absorbed into the sprawling disk of our galaxy, their identities erased by the slow but relentless work of gravity. What makes these satellites even more fascinating is the role they play as laboratories for dark matter. Many of them appear to be dominated by it, with visible stars representing only a tiny fraction of their total mass. Some are so dark matter rich that they have almost no gas left to form new stars, existing instead as ghostly gravitational wells marked only by a handful of dim suns. Studying these galaxies allows astronomers to probe the nature of dark matter in ways impossible within the brighter, more complex Milky Way. They are faint, fragile, and easily disturbed, and yet they may hold some of the deepest secrets of cosmic physics. But the Milky Way's family extends beyond satellites. Together with the Andromeda Galaxy and the smaller Triangulum Galaxy, the Milky Way forms the core of what astronomers call the Local Group, a collection of over 80 galaxies bound together across 10 million light-years of space. Most of the members are tiny dwarfs clustered around the giants, but the two main players, the Milky Way and Andromeda, dominate the group with their immense size and mass. This neighborhood is not static. It is dynamic, restless, and destined for collision. Andromeda is currently rushing toward us at a speed of 250,000 miles per hour, and in about 4.5 billion years, the two giants will crash together, merging into a new, larger galaxy. The Local Group is not just a gathering of galaxies, it is a stage for an inevitable drama, a gravitational ballet that will reshape everything we know. Seen on the grand scale, our galaxy is just one bright island among many, drifting through the darkness in the company of others. The satellites that orbit us, the rivers of gas they shed, the local group we belong to, all of it is part of a larger structure stretching across millions of light-years. And even this is just a fragment of something greater still, because the local group itself is pulled into a vast cluster, a superstructure containing thousands of galaxies bound together in a gravitational embrace that dwarfs everything we've seen so far. If the Milky Way is our home, and the local group our neighborhood, then the next step outward is the city, a cosmic metropolis known as the Virgo Cluster. Beyond the Milky Way and its companions, beyond even the local group of galaxies, lies a stage so vast it almost defies comprehension. Here the scale of structure leaps again, from tens of millions of light-years to hundreds, and we begin to see how galaxies themselves gather like stars in a cluster. The local group is just one small member of the Virgo cluster, a sprawling congregation of more than 2,000 galaxies bound together by gravity. From our vantage point, it lies roughly 54 million light-years away, but its gravitational influence already tugs on us, pulling the entire local group slowly toward its crowded heart. Imagine standing on Earth and watching cities drift together across a continent. This is the same, only the cities are galaxies, and the continent is the fabric of space itself. At the center of the Virgo cluster lurk galactic titans, giants so massive they make the Milky Way look modest. Chief among them is Messier 87, an elliptical galaxy containing trillions of stars and one of the largest black holes ever discovered, over 6 billion times the mass of our Sun. From its core erupt jets of matter and energy that stretch thousands of light-years, visible across the electromagnetic spectrum. This is not just a galaxy, it is a cosmic furnace, devouring gas and stars while blasting out energy that can shape the fate of the entire cluster. Around it swirl countless other galaxies, some spirals like our own, others distorted into irregular shapes by gravitational interactions. The cluster is a crowded, violent environment, a galactic downtown where collisions and mergers are routine. Clusters like Virgo are not quiet gatherings of galaxies orbiting politely. They are dynamic ecosystems, filled with drama. Hot gas fills the spaces between galaxies, heated to tens of millions of degrees, glowing in X-rays, detectable only with specialized telescopes. This intracluster medium contains more matter than all the stars combined, a reservoir of energy and particles constantly stirred by supernovae, galactic winds, and the immense pull of dark matter. It is in this invisible atmosphere that galaxies swim, sometimes colliding head-on, sometimes stripped of their gas by the friction of their motion. These encounters can quench star formation, transform spirals into featureless ellipticals, or spark bursts of new stars as gas clouds are compressed. To watch a galaxy cluster is to witness galactic evolution in action, a process that sculpts the universe itself. But even the Virgo cluster is not the final step outward. It is part of an even greater arrangement, a supercluster of galaxies, called the Virgo supercluster, stretching 110 million light-years across and containing tens of thousands of galaxies. For much of history, this was believed to be the largest coherent structure in our cosmic address. Yet recent discoveries have shown that even this is only one strand of something far grander. The Laniakea supercluster, a name meaning immeasurable heaven in Hawaiian. This immense structure spans over 500 million light-years and contains the mass of 100 million billion suns. It is here that the true scale of cosmic architecture begins to reveal itself. Within Laniakea, galaxies and clusters flow like rivers along gravitational channels, drawn toward dense regions while leaving behind vast voids, cosmic deserts containing almost nothing. At its heart lies a mysterious focal point astronomers call the Great Attractor, a gravitational anomaly pulling entire clusters, including Virgo, and with them our local group, at speeds exceeding 1 million miles per hour. From Earth's perspective, this pull subtly distorts the motion of galaxies around us, bending their paths towards something hidden behind a dense wall of dust and gas in our sky. We cannot see the Great Attractor directly, but its influence is undeniable, a gravitational current shaping the fates of entire galactic superclusters. When we look at these structures, clusters, superclusters, filaments, we begin to see the universe as a vast cosmic web. Galaxies do not float in random isolation. They arrange themselves along filaments of dark matter and gas, stretching across billions of light-years. Between these filaments lie the voids, empty expanses so large that light can take hundreds of millions of years to cross them. Our galaxy, our cluster, our supercluster, are just one glowing thread in this enormous tapestry, a strand in the web of creation. The journey from Earth to the center of the Milky Way already revealed unimaginable scales of distance and power. But zooming outward to the Virgo cluster, the Laniakea supercluster, and finally the cosmic web itself takes us into realms so vast they strain the limits of human imagination. We are not merely citizens of a galaxy, we are residents of a cosmic city, part of a supercluster, flowing toward an unseen attractor, woven into a web that spans the visible universe. And beyond even that, there is a final mystery, the invisible forces driving the expansion of the cosmos itself, the dark energy that pushes galaxies apart faster and faster, reshaping the ultimate fate of everything. We began this journey anchored to a small blue world orbiting an ordinary star, one among hundreds of billions scattered across the Milky Way. From there we moved outward, through the quiet shelter of our local bubble, across stellar nurseries glowing with new suns, past the ruins of ancient stars compressed into white dwarfs, neutron stars, and black holes. We traced the spiraling arms of our galaxy, followed them inward to the crowded star clusters, and finally stared into the abyss at the heart of it all, Sagittarius A, a monster of gravity and time that binds the Milky Way together. Then we pulled back again, watching as our galaxy merged into a neighborhood of companions, joined with Andromeda and Triangulum to form the local group, swallowed by the Virgo cluster, swept into the vast Laniakea supercluster, and stretched across the filaments of the cosmic web. Each step revealed something larger, stranger, and more humbling than the last. And yet through it all, one fact stands unshakably true. Every single thing we've seen is part of the same story, a story of matter and energy, arranging themselves into complexity, a story of creation and destruction, balanced across unimaginable scales. What makes this journey remarkable is not only the beauty of the cosmic architecture, but the recognition of our place within it. The calcium in your bones, the oxygen in your lungs, the iron in your blood, all of it was forged in the fiery hearts of stars that lived and died long before our planet formed. When those stars exploded, they scattered their atoms into space, where gravity gathered them again into new clouds, new stars, and eventually new worlds. The very atoms that allow you to exist are recycled stardust, borrowed from the galaxy's endless cycle of birth and death. When you look at the night sky, you are not looking at something separate from yourself. You are looking at your own origin story, stretched across light years of darkness. The Milky Way is not just a backdrop, it is your home, your ancestor, your body written large across the cosmos. And yet, even with everything we know, the mysteries are deeper than the answers. Dark matter outweighs all the visible stars and planets, yet we still cannot touch it or even confirm what it is. Dark energy drives galaxies apart at ever-increasing speeds, yet we have no clear understanding of its nature. Black holes devour everything that comes too close, yet they may also hold the key to linking gravity with quantum mechanics. Each discovery widens the horizon rather than closing it. The more we learn, the more profound the questions become, as if the universe is designed to stretch not only our imagination but our capacity for wonder. But perhaps the most astonishing part of this story is not out there among the stars. It is here, in us. Out of the countless galaxies in the observable universe, out of trillions upon trillions of stars and planets, consciousness has emerged on a small rocky world orbiting an ordinary sun. Matter has arranged itself into forms complex enough to not only survive, but to look back at the cosmos, measure it, map it, and tell its story. You are the universe becoming aware of itself, a fleeting expression of atoms that once belonged to ancient stars, now contemplating the black holes, the spiral arms, and the cosmic web that gave rise to them. In this sense, our place in the Milky Way is not insignificant. It is extraordinary. The future of our galaxy is written in long time scales. In billions of years, the Milky Way will collide with Andromeda, reshaping both into a new galaxy under the pull of their central black holes. Star formation will fade as gas is consumed until only the dim red embers of the smallest suns remain. Eventually, even black holes will evaporate into darkness. The story of the Milky Way, like all galaxies, will end, and yet that end does not diminish the wonder of the present. It is precisely because everything is temporary, stars, galaxies, even the universe itself, that this moment matters. To exist here now with the ability to look up and understand even a fraction of the cosmic dance is a privilege beyond measure. So the next time you stand beneath the night sky, remember this. You are orbiting a star carried on the arm of a galaxy racing around a black hole, drifting within a cluster, woven into a supercluster, connected by the threads of the cosmic web. You are a traveler on a journey across scales, so vast they defy comprehension, and yet you are also made of this universe, inseparable from it, a reflection of its brilliance. To understand the galaxy is to understand yourself, and in that sense, every glance upward is a reminder. You are not just in the universe, you are the universe briefly awake, staring back at itself across the endless night.